Hello there, 8th graders. This is Mrs. Minowitz, and I'm here today to talk to you about stars and the Milky Way galaxy and some different things that you are going to be working with in class today, and to kind of give you an overview of what you need to do. So the first thing you're going to need is your note sheet or the worksheet that you're working on in class today. You're going to be working on filling in this information at the top here based on this video. So the blank lines here, it says use video linked here, you're in that video. And then you're going to be working on filling this in. So the first thing that this asks you to do is to put an order from smallest to largest. So the things that I want you to rank are the Earth, the universe, a galaxy, and the sun. So thinking about recording them in order from smallest to largest. Think about your predictions, what would be smallest and then what would be largest, and we'll fill that in here. You can put that onto your sheet right now. Okay. So this smallest thing that we have on the list is Earth. Planets are smaller than many other things in the solar system, or in any solar system, although they are not necessarily the smallest things in space. There are many things that are smaller. After the Earth, the next smallest thing here would be the sun, which is actually quite large. The sun, stars. The sun is a star, and so it would be larger than the planets. And then after that, we have a galaxy. So a galaxy is a collection of stars and solar systems that would one unit larger than the sun. And then the last thing would be the universe, because that includes everything and all galaxies. So when you rank in your list, Earth smallest, galaxy, or sun, then galaxy, then universe, in ranking the size of things. Okay. So we are in the Milky Way galaxy. Okay. That is where we are at. And the sun is just one of billions of stars in the Milky Way galaxy, though. So the Milky Way galaxy includes many, many, many things other than just our sun and the planets within our solar system. So the sun is one of billions of stars in there. So if you take a look at this depiction of the Milky Way galaxy, if you were to take a look at how large it actually is, or what it actually looks like, it is what is called a spiral-shaped galaxy. So it looks kind of like a big circle or spiral. And the sun is actually moving in there. If you see those little arrows on this diagram, the sun does actually move around, like spin, our galaxy spins, and it moves there. Now the thing that I want you to notice across the top here is it says 50,000 LY. Okay? Our galaxy is 50,000 LY across. And LY stands for light years, which is the next thing on your note sheet. Looking at light years. Now, the most confusing thing, about light years, is that they are a distance. And I know that seems weird because a year is a unit of time, but a light year is actually a distance, which is the tricky thing. A distance that light travels in 1 year, and this is about 9.5 trillion kilometers. This is used when we're talking about distances, when we're talking about things like galaxies. So when we went and we talked about the Milky Way galaxy and said it's 50,000 light years across, it takes light 50,000 years to travel across it. So it's interesting to think of if we were to look at the edge of our galaxy and that light was coming from a star at the edge of the galaxy towards the center of it, it would take 50,000 years for the light to reach there because of how far away it is. So light years are clearly a very large distance. We use them when we are talking about things with galaxies, really large distances. We do not use light years when we are talking about our own solar system. We use astronomical units because light years are too big. Okay, they're too big of a unit for this. We would have way less than 1 light year within our solar system. So it doesn't make sense to use a light year. Okay, instead we do use astronomical units, excuse me. So the other thing we're going to talk about with stars is what is called their life cycle. So just like people who go through life, you start off as a baby, you get a teenager, you're an adult, you're elderly, you go through your life cycle. Stars do the same thing, and a couple of different things are going to happen depending upon the mass of those stars. So where stars start out is in what is called a nebula. Okay, so this is a picture of the Crab Nebula, but this is where stars are born, and that's where they're formed. So we're going to start off with, this is where we get stars. Now, the picture on your note sheet shows what happens to stars throughout the course of their life, depending upon their mass. So a stellar nebula, or where stars are born, we can take one of two tracks. We can take the average star track, and throughout its life cycle, it's going to go from being an average star over to being a red giant, then a planetary nebula, and eventually at the end of its life cycle, it'll become a white dwarf. Now, if we have really massive stars, on the other hand, they are going to go down a different path, okay? And they'll become what are called red supergiants. Then there's a supernova, which is this really large kind of like explosion thing. And depending upon their final mass, they're either going to become a neutron star. Those are for big stars that aren't big enough to become black holes. So really large stars, or really massive stars, I should say, actually end up becoming black holes throughout their lifespan at the end of it. So it's going to depend upon which path they follow based upon their different masses, which is what you're going to look at more when you're done with this video. Now, our star, our sun, is a medium-sized yellow star. Okay? That's something to fill in on your note sheet. It is going to follow that top track on your diagram. So our sun, okay, is an average star. It's over here. It's average. And it's going to stay in that stage for quite a while. But eventually, it will become a red giant, planetary nebula, and white dwarf billions of years from now. And if you actually get to the end of the worksheet and you there's some other videos to watch, it shows you more about what will happen to our sun over time when it would go to those other stages. However, we do not have to worry about that right now because we are talking about still billions of years, several billion years, they think, before it would become a red giant. So we've got some time. When thinking about comparing our sun to things in the rest of the things in the solar system, we already talked about how much larger it is than the Earth. This picture is showing a comparison of the star of the sun compared to the approximate size of the planets. So we are tiny in comparison to the sun. And the sun is only an average star. We'll actually watch a video later on in class where we look at and compare the sizes of different stars, because the sun is just an average one, and there are some that are much, much larger than the sun. So we will get there eventually. But do know stars are way larger than planets, at least when they're on what's called the main sequence. This diagram shows, okay, an example of this. Okay. The sun here is 1 pixel, so it's like one tiny little dot, and this compares the size of other stars. So there are stars that are much, much larger than our sun. Okay. Now, I want to talk about a couple of those different ending spots there. So we said, hey, high mass stars follow along this path, and then they can become either a neutron star or a black hole. So a neutron star is very, very dense. Okay? Everything in it is compacted so much. It actually gets its name because it creates neutrons, because things are compacted together so much. If I had a teaspoon of it, so think about how big a teaspoon is, it's going to weigh 1 billion tons on Earth. Okay, so a little tiny thing that you like cook with, right? Small amount would weigh 1 billion tons. And if you had a sugar cube of it, it would weigh almost as much, or it would weigh as much as all of humanity or all people put together. It is very, very dense. That's one ending option for high mass stars. The other ones are black holes. Okay, and you're missing that top line there on your note sheet. And its gravity is so strong that not even light can escape a black hole. Okay, we can't detect it because of light. We actually detect it because of X-rays that are released when particles from other stars are pulled into it. Most astronomers believe the Milky Way galaxy contains millions of black holes. They actually think that there is a large black hole in the center. One of those other video options at the end of class is to look at a video looking at what black holes are and kind of explaining what we know about them and some different things that would happen. So if you get to that point, I would highly encourage you to watch that. That is a really good video clip. This is an image from a telescope of the supermassive black hole at the center of the Milky Way galaxy. It has a mass of about 4 million suns, but it would be smaller than the sun in terms of how dense it is compacted together. So clearly much more dense even than a neutron star. So at this point in time, looking at your note sheet, okay, and looking at what you have done and what you have accomplished, okay, you should have filled in the stuff here on top of this diagram, okay, right? Everything, okay, through here you should have filled in by watching this video. Okay. Now, the next direction I want to give a couple clarifying things too. So I'm going to scroll down here and erase this part here, sorry. Okay. I'm going to scroll down there. Okay. And if you take a look here, it says go to the website linked here. So you'll go to that website, but I want to explain a couple things. It says go to chapter 28. So if you look up here on the top, it says chapter 28. Okay. And then it says what happens as a star runs out of hydrogen. You are going to click on that. Now, the issue that I want to talk about with you is a technology thing here. So depending upon your account and your settings, you're probably going to see this thing here that says click to enable Flash Player. Okay. So if you click on that, okay, it's going to say, hey, do you want to let Flash run? And you're going to say allow. Okay. And then it should pop up with an image here. And you're going to need that image. Okay, or there's some video things they're going to play here later on with this. And so you'll want to do that. Now, if for some reason that does not pop up, that likely means that something is in your setting. You need to change your settings. So you'll have another thing that pops up, typically over here by this star, okay, over in here. And if you'll click on that, okay, oh, I didn't want to hit the bookmark button. But if you will click on that, it will go through and you can adjust your settings. Because if you look at my settings, if I click on this one here, it says Flash allow. Sometimes people have Flash set to block as opposed to allow, right? So it says allow here. Sometimes people have it set to block. And if that is the case, you might need to adjust those settings to say ask, and then you might need to reload the page in order to have this come up. And we've done this in class before, so this should hopefully sound familiar. And if you're struggling, please ask for help, or please ask a neighbor, the guest teacher that's in here, things like that. So when you get here, you're going to be working on answering the different questions. I will tell you that you're going to need to watch the different animations. There are sometimes words and things in here that you will need. Sometimes there's not. Like this one doesn't have a ton of extra words in here. That's fine. But one thing I will tell you is there are 6 steps. Okay, with this, you'll see them across the bottom. You can't really read them very well right now. Steps 1 through 6 here. And if you look at your assignment sheet, okay, and you look at, oh, I need to go to the assignment sheet, at steps 1 through 6, okay, it tells you where you can find the different things. I think you skip step 5. Okay, so if you're looking for an answer, you want to look in that section. Okay, you skip step 5. So you're going to go through, hopefully answer those questions. Your goal would be to get through that, and depending upon how quickly you get started, that may or may not be an option for you in class. If you do finish with that, I did link in some of those different videos down here, okay, with black holes, what's going to happen to the sun over time, and things like that. So I hope you have a wonderful day. I hope you get this finished and turned in. If you have questions, please talk to me in class.